AI systems create new signals and new attack paths. In this topic, we'll use Microsoft Sentinel and Splunk to connect model, identity, cloud, and data telemetry, detect behaviors like prompt injection and retrieval abuse, and turn findings into response-ready incidents. We've already built the core security foundation: architecture, identity, application controls, guardrails, RAG, cloud posture, and supply chain. Topic 5.1 defined what to log. Now we'll turn that telemetry into Sentinel and Splunk detections that drive alerts, dashboards, and response. Traditional SIEM content was built around infrastructure evidence, endpoint alerts, identity events, network flows, and cloud logs. AI systems expand that detection surface. The signal may be a suspicious prompt, a retrieval spike, abnormal token use, a failed guardrail, or a sensitive answer leaving the model. Re-engineering means correlating classic security telemetry with AI-native behavior across application, identity, data, and model layers so teams can catch abuse that infrastructure monitoring alone may miss. AI detection starts by choosing behaviors that actually signal risk, not by flagging every strange prompt. Look for combinations: injection attempts against instructions or tools, repeated guardrail bypasses, unusual model activity like spikes, switching, or off-hours use, and excessive token consumption. Connect those signals to retrieval patterns and data access. The clearest detections usually answer 4 questions: who asked, what they accessed, how the model responded, and whether the behavior changed. Prompt activity is an important signal, but suspicious wording is only the beginning. Classifiers and guardrails can identify override attempts, role manipulation, hidden prompt requests, and tool abuse. From there, correlate those events with session history, source patterns, repeated attempts, and actual application outcomes. Severity rises when behavior persists across users, tenants, IPs, or models. Tune the logic so red team testing and developer experiments are separated from true malicious bypass activity. Unusual model usage is often visible before the damage is obvious. Baseline requests, token counts, model choices, and cost by user, app, department, location, and time window. Then look for sharp deviations: sudden request spikes, unusually long conversations, premium model use by unexpected roles, or bot-like patterns. Higher confidence alerts combine token anomalies with identity risk, unusual IPs, billing changes, sensitive retrieval, DLP hits, or guardrail violations. In RAG, suspicious activity often appears before the final answer. Watch what the retriever asks for, which vectors are searched, and which source documents are opened. Compare that behavior to the user's role, project, location, and data entitlements. A single unusual query may be harmless, but high-volume retrieval, rare index access, sensitive classifications, or cross-border movement should raise risk, especially when followed by extraction prompts, unsafe output, or external transfer. Treat Sentinel as the correlation layer for AI security, not just another log store. Bring in Entra sign-ins, conditional access, Defender, Azure Activity, Key Vault, Purview DLP, and workload telemetry. Add custom AI events for prompts, guardrail outcomes, token usage, retrieval context, and model responses. Use consistent fields like user, session, app, model, IP, document, and risk score, so identity, workload, and data exposure signals connect. In Sentinel, detection quality depends on how well KQL turns raw events into context. Filter AI guardrail or application logs into a clear time window. Summarize repeated behavior by user, session, app, or IP. Join that activity with identity risk, DLP alerts, and cloud logs. Add watch lists for privileged users or sensitive systems, and map entities so incidents open with the people, resources, and relationships analysts need. For Splunk, the goal is turning scattered AI telemetry into consistent, searchable security data. Ingest application logs, API gateway activity, identity events, DLP signals, cloud logs, guardrail decisions, and vector database access. Normalize fields like user, source IP, app, model, risk, action, and token count. Once that foundation is reliable, dashboards can show usage and cost trends, while correlation searches combine signals to detect suspicious AI behavior faster. Aligning to SIEM makes those detections reusable. Risk-based alerting changes the question from, did one event look bad enough, to, is this pattern becoming dangerous? A blocked jailbreak, sensitive retrieval, token spike, and suspicious IP may each be low confidence alone. Splunk assigns scores, aggregates them around a user, app, session, model endpoint, or workload, and applies modifiers for privilege and data sensitivity. When the score crosses a threshold within the time window, the correlation search escalates. Strong AI detections begin with a specific threat hypothesis, such as confidential data being pulled through a RAG workflow. Before writing rules, confirm the telemetry is present, trustworthy, time-stamped, and easy to correlate. Design the logic and prove it with controlled events, such as prompt injection or data leak simulations. Tune thresholds and allow lists to reduce noise. Assign severity based on impact, and connect each alert to a clear response action. Severity scoring turns noisy AI alerts into consistent decisions. Ask who is involved, what data or system is touched, whether controls block the action, and how confident the detection is. A privileged user probing sensitive retrieval results is different from a low-confidence prompt anomaly. Once severity is assigned, it should select the right playbook: triage, data leak investigation, account compromise, endpoint abuse, or agent containment, with actions like revoke, isolate, preserve, and notify. Here's how weak signals become a real incident. A risky sign-in alone may not prove compromise. Prompt injection attempts add context, especially when guardrails start blocking bypass language. The same session then pulls unusually large volumes from a sensitive index. If DLP finds confidential data in output or export activity, the SIEM can correlate everything, raise severity, enrich the user and resource entities, and open an investigation playbook for analysts. Effective AI security analytics starts with the right telemetry: prompts, guardrails, model usage, retrieval activity, identity, cloud, and DLP signals. Sentinel and Splunk turn that data into detections when it is normalized, enriched, tuned, and tied to playbooks. Next, we move from detection into incident response and forensics.